Welcome to my channel. In the last video, I have discussed definitions of isolated and non-isolated kind of singularities. There I have classified the isolated kind of singularities and solved a lot of problems regarding poles removable singularity and essential singularity. Now, in this video, we shall be concerned with the identification of isolated and non-isolated kind of essential singularity. Now, just to recall the definitions of isolated and non-isolated singularities, that Z0 is a singularity of the function fz. Now, Z0 will be called isolated if fz is analytic in a deleted neighborhood of Z0. That means we can construct some neighborhood of Z0 where fz is analytic at every point except Z0. That is, the neighborhood is free from the other singularities. Of fz. Now, Z0 will be called non-isolated if we are unable to construct such neighborhood. That means we cannot find any neighborhood of the point Z0 which is free from some other singularity of the function fz. So here we are unable to find some neighborhood of Z0 which is free from other singularities of the function fz. That means there does not exist any deleted neighborhood of Z0 where the function fz is analytic at every point. So this is about isolated and non-isolated singularity. Now let's see how to identify isolated and non-isolated kind of singularities. So here we have a very important theorem that says Z0 is an isolated essential singularity if Z0 is a limit point of set of all zeros of the function fz. Now this Z0 is a non-isolated essential singularity if Z0 is a limit point of set of all poles of the function fz. So here we have an isolated essential singularity whenever the point Z0 is the limit point of set of all zeros of the function fz, and Z0 is a non-isolated essential singularity if Z0 is a limit point of set of all poles of the function fz. For example, if we take fz equal to sec 1 by z, which can be written as 1 by cos 1 by z. So the zeros of the function cos 1 by z are the singularities of the function fz. So if we equate this to 0, that results in 1 by z equal to 2n plus 1 pi by 2, where n equal to 0, plus minus 1, plus minus 2, etc. So here we are getting Zn equal to 2 by 2n plus 1 times pi for n equal to 0 plus minus 1 plus minus 2. These are the singularities of the function fz. Now z equal to 0 is also a singularity of the function fz. Not only that, 0 is a limit point of Zn, because as n tends to infinity, Zn tending to 0. So 0 is a limit point of the set of all poles to by 2n plus 1 times pi for n equal to 0 plus minus 1 plus minus 2, etc. So here we can see 0 is a non-isolated essential singularity of the function fz. Next, let us take fz equal to z by e power 1 by z minus of 1. Now to get the singularities of the function fz, for singularities, we'll equate the denominator part to 0, e power 1 by z minus of 1 equal to 0. So from here we can write, so that is equal to e power 2n pi I for n equal to plus minus 1 plus minus 2, etc. That is due to Euler, we have e power 2n pi I equal to cos 2n pi plus I sin 2n pi, which is equal to minus 1 power 2n plus I times 0, that is equal to 1 plus 0. So it is always 1 for all n equal to plus minus 1 plus minus 2, etc. So from here we are getting 1 by z equal to 2n pi I. That implies Zn equal to 1 by 2n pi I. So these are the singularities of the function fz. Now their limit point is also a singularity of the function fz, z equal to 0. So what is the limit point of Zn? So as n tending to infinity, Zn tends to 0. 0 is a limit point of set of all singularities of the function fz, which are pole kinds of singularities. Set of all poles of fz. So we conclude that 0 is a non-isolated essential singularity. Fz equal to sin pi by z. So here z equal to 0 is the singularity of the function fz. Z equal to 0 is a singularity of fz. Now if we equate fz to 0, we'll get the set of all zeros. So from here we are getting pi by z equal to n pi, n equal to plus minus 1 plus minus 2, etc. So Zn is equal to 1 by n. for n equal to plus minus 1, plus minus 2, etc. So here we can see the set of all zeros of xz is 1 by n for n equal to plus minus 1, plus minus 2, etc. And the limit point of set of all zeros is 0, because as n tending to infinity, Zn tends to 0. So 0 is a limit point of the set of all zeros So here we'll conclude that 0 is an isolated essential singularity of the function fz.